Good morning and welcome back. Post Thanksgiving. Still smells like gravy over here. We got 3 weeks of school in 2020. Okay, this is the last day of November. Okay, so we're going to sprint these last 3 weeks and then we get 2 weeks off. I hope you enjoyed your Thanksgiving break and you are ready to work hard for 3 weeks. Let's sprint to the finish line, finish up this quarter, finish up this semester, finish up your 2020 school year, right? And then you'll be halfway done with sixth grade. All right, you know the drill. All right, let's show some integrity. Copy this down. Go do all that you can. This is the bonus hard one here for the diamonds. Put a star next to it if you get that. Pat yourself on the back for sure. Okay, and then we're going to review some exponents, review some adding integers. Remember, think when you're adding, think of money. A negative is how much money you owe somebody. A positive is how much money you got in your pocket. Okay? Uh, Area and perimeter. Remember, you're adding up all the way around a shape for the perimeter, and you are going to multiply to get the area. Area is always square units. Make sure you get your units right. And then we have some basic adding and subtracting fractions with like denominators, and then they get a little trickier. Okay, see if you can remember what to do. Remember, you can't add dollars and pesos. You got to change the denomination so it's the same. So we want to change the denominator on these, figure out what a denominator would be for one whole. How many fifths is one whole? Hint, hint. All right, go have at it. I will see you in a few minutes when you're done with that for you to check your answers or get the ones that you missed. Okay? All right, welcome back, everybody. Let's do this. 48 and 14. Remember, this is the product and this is the sum. Product is the answer to multiplication problem. The sum is the answer to an addition problem. What two numbers, when you add, get 14, but when you multiply, get 48? What is that? Hopefully you got that as a 6 and an 8, right? 6 plus 8 is 14. 8 plus 6 is 14. 6 times 8 is 48. 8 times 6 is 48. That idea that you can go in any order when you multiply or add is called commutative property. Okay, like someone's commute. It's the same thing frontwards as backwards, right? Driving to work is the same distance as driving home from work. On to the next one, 54 and 15. Hopefully you got that. 9 times 6 or 9 plus 6. Now we get into the decimals, get a little trickier. What two numbers multiply equal 9 and added equals 6? 3 and 3, right? Where am I putting the decimal? Well, I moved it over 2 spots to get that 9, right? 3 times 3 is 9, but I moved it over 1 spot to pretend that was a 3, 1 spot to pretend that was a whole number 3. So that's a total of 2 spots. I got to go back 2 spots. And when you add, you make sure you line up those decimals. So 3 tenths plus 3 tenths equals 6 tenths. Boom. All right. The tricky one, 6 times 7 is 42, but 6 plus 7 is not. But you know what? Here's a trick for you. 6 times 7 is 42, right? If I double one number and take half the other number, 3 times 14 will also equal 42. I could have doubled that. We got 12. Take a half of 7, 3.5. Guess what? 3.5 times 12 will also equal 4.42. So that works. 3 and 14, but I'm putting the decimal over 1 spot for each because I moved the decimal over twice there. Okay. All right. Hopefully you got that. 3 to the 4th power is not 12. It's 3 times 3 times 3 times 3. And you can go in order. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is the same as 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. Okay. Again, 4 times 3 is not, 4 times 3. This is not 4 times 3 or 12. This is 4 times 4 times 4. Okay. And this time I get 16 times 4. That's 4 tens and 4 sixes. 40 and 24 equals 64. Okay. 5 to the 3rd power is not 15. It's 5 times 5 times 5, which is 25 times 5. 5 quarters is 125. 3 to the 5th power is not 15. It's 3 times 3 times 3 times 3. Now I'm going to cheat here. I just did all this work to get 3 to the 4th power. That's 3 to the 4th power, right? 81 times 3. That's 3 80s, 240, and 3 1s, 3, 243. All right. 2 to the 4th power. I'm pretending there's no decimal, right? I'm going to pretend there's no decimal. And just multiply. 4 times 4, 2 times 2 times 2 times 2. That is 4 times 4 is 16. But where am I going to put the decimal? Well, I moved it over once there, once there, once there, once there. I got to go back 4 spots. 1, 2, 3, 4. Fill in the egg carton. That's 0.0016. Challenge one. How'd you do? All right. I owe $4, plus I have $5. I can pay all 4 that I owe and still have 1 left over. I owe $6, plus I owe $4. Oh man, I owe a ton. I owe a total of $10. I owe 7, but I have 4. That's a good thing, right? I can pay that 4, but I'm still going to owe some. How much will I still owe? 3. Okay. All right. All the way around, 1.2 plus. Now, I recognize that those two numbers are what we call compatible numbers. Compatible numbers fit together well, right? Like peanut butter and jelly, right? Like whipped cream on top of, I was going to say hot cocoa, but whipped cream tastes good on everything almost, right? Well, maybe not tacos. All right, so compatible means they fit together well, because when I add 1 2/10 and 8/10, I get 2. 2 is halfway around. So how much is all the way around? The perimeter is 4 meters. Now, when I get the area, I got to multiply. I'm going to pretend like there's no decimal and do 8 times 12. That's 8 tens, 80. And 8 twos, 16. 80 and 16 is 96. Now you could have done 8 times 2 is 16. Put the 6 here, carry the 1. 8 times 1 is 8, plus 1 is 9, 96. Just showing you how you can do some of these in your head. All right, now that was really an 8/10. I had to move that over 1 spot to pretend it was 8 holes, right? And that was really, instead of 12, 1 2/10. I had to move the decimal over once to pretend it was a whole number, 12. So I had to move it over once there, once there. I got to go back 2 spots in my answer. So the area is 0.96 square meters. Make sure area is always square units. Drill that in your brain. Okay. All right. Now, 8 plus 2.5. Where's the decimal in the 8? If you can't see it, and it goes to the right. Remember, $8 equals $8.00. All right, that's how I remember that. So this will get me halfway around, 10.5. So I'm going to go 10.5 again, and I get 21. Okay, so the perimeter equals 21 inches. What's the area? 8 times 2.5. 8 times 25 is like quarters, right? 25, 50, 75, 1. 25, 50, 75, 1. Right? So that's $2. 8 quarters is $2. So 8 times 25 is 200. Where do I put the decimal? Well, I had to move it over 1 spot there to pretend it was 25. So I got to go back 1 spot. Okay, so the area equals 20 square inches. Area is always, yeah, I heard you, square units. All right, I have 3 11ths plus 4 more 11ths. That is 7 11ths. Don't add the bottoms. Okay, you'll multiply the bottoms when you're multiplying, but when you're adding or subtracting, you get the bottom the same, and you just deal with the top. Okay, 8 13ths minus 4 13ths leaves me with 4 13ths. 9 elevenths minus 7 elevenths leaves me with 2 elevenths. All right, this 1 whole is how many fifths? 1 whole is the same as 5 fifths. 5 fifths minus 3 fifths leaves me with 2 fifths. That was much easier than you thought, huh? All right, I cannot add fourths and eighths. I have to change the denominator so the number on the bottom is the same. Now, 4 fits into 8. That means I have to do half the work. I'm going to leave 1/8, 1/8, and I'm going to change 3/4 to eighths. What did I do to the 4 to make it 8? I multiplied it by 2. Remember, this is like the magic 1. I can multiply anything by 1, and I don't change its value. I just get a new name for it. All right, so if there's a 2 on the bottom and this is 1, there's a 2 on top, and 3 times 2 is 3/4 is the same as 6/8. You want to see a picture of that? Okay, these are fourths. I'm going to shade in 3 of them. Now I got eighths. I had 3/4. Now I have 1, 2, 3, 4, 5, 6 eighths, right? See that? All right, I'm going to lie to you. So 3/4 equals 6/8. So now I have 6/8, and I'm going to add 1/8, and I'm going to get a total of 7/8. Same idea here. 3 fits into 12. So I'm having 11/12 stay the same, but I'm going to change this 2/3 to 12ths. 3 fits into 12 how many times? 4. So I multiply 3 times 4. I got to go 2 times 4. Now I had 11/12. I took away 8/12. That leaves me with 3/12. Now that's a pretty good answer. You want the bonus? Simplify it, right? I found a number that goes into the top and the bottom. What is that? Well, 3, right? 3 goes into 3 1 time, and 3 goes into 12 4 times. That's like a reverse of the magic 1. 1 times 3 is 3, 4 times 3 is 12. When we simplify, it's like magic 1 in reverse. Hopefully you got those. Hopefully you're ready. Work hard for 3 weeks, right? Let's do this thing. You got this. Yeah. You guys remember tool time? All right. Have a good week, you guys.